Okay, in this part 3 of the application problems, we have to apply what we know about lateral area, surface area, and volume to answer real-life questions. So this question asks us which paint roller would spread more sealer on one revolution of the cylinder represented by a paint roller. Well, since the paint does not get on the bases, we only have to find the lateral area, which is just this middle part, is where the paint would be on. So to find the lateral area of a cylinder, we just use the circumference of our base times our height. The circumference of our base is the length around here. This lateral area has to wrap around that. Remember, in a net, the cylinder's net looks like this. So we don't need these parts, we just need this. But this is going to be pi d, which is the circumference times our height. So that's the formula we're going to use. Pi dh. So the diameter of our circle is 3, and the height between our bases is 10. So this paint roller has 30 pi coverage on one revolution. So let's try this one here. The lateral area is the circumference times the height, which is going to be pi d times the height. Diameter is 2, so this is 2 pi times the height, which is 12, which is 24 pi. So this is in inches squared, and this is also inches squared. So as you can see, this paint roller would spread more paint. So the first roller will spread more paint. Okay, in number 2, it asks us which is the better buy if the cost is the same. 2 cans of breadcrumbs where each has a diameter of 5 inches and a height of 7, or one with one large can of breadcrumbs with a diameter of 8 inches and a height of 6 inches. So let's draw these two cylinders. So the first situation, we have 2 cans with a diameter of 5. So the diameter is 5 and the height is 7. So we have 2 of these, 5 and 7, or one big can, one large can, with a diameter of 8 inches and a height of 6. So we need to find the volume of A and of B to determine which one is a better deal. Now remember, they both cost the same. So volume of A is going to be area of the base times the height. Base is pi r squared, so we'll use half of the diameter, which is 2.5, squared pi for the area of the base, and the height is 7. So 2.5 squared times 7 is 43.75 pi. Now remember, there's 2 cans, so 2 cans is going to equal 43.75 times 2. And that volume will be, let me move this so you can see it, 87.5 pi. And that's inches cubed. So volume of B will again be area of the base times the height, which is pi times the radius, in this case is 4, since the diameter is 8, times 6, which is your height. So we can get a volume 16 times 6 is 96 pi. So our calculations show that the larger can is better than buying 2 cans since they are the same price, because the volume of the 1 can is much larger than, or is a little bit larger than the 2 cans put together. So our answer is the large can is the better deal. Let me write that. The large can is the better deal. Okay, and the next problem says a pyramid has a volume of 729 cubic units. If the area of the base is 243 square units, what is the height of the pyramid? So if we're dealing with a pyramid, we need to use the volume of a pyramid formula because they're giving us volume. So in a pyramid, again, we have the area of the base times the height divided by 3. So we can just substitute in all parts of the formula. The volume is 729. The area of the base is 243, so that goes in for capital B. We're looking for capital H, the height, divided by 3. So we just need to solve for H. To do that, we'll get rid of this division by 3 by multiplying. So 729 times 3 is 2,187. And that will give us 243 times the height. So to solve for the height, we'll just divide 2,187 by 243 and get 9 for the height. So the height of the pyramid is 9 units. Okay, the base of a right prism has an area of 25 square meters. The prism is 4.2 meters high. Find the volume of the prism. So we'll use the volume of a prism formula, which is area of the base times the height. So it says the base of a right prism has an area of 25 square meters, so we can substitute the 25 in for the area of the base, and it has a height of 4.2, so we can substitute 4.2 in for the height, and just solve by multiplying 25 times 4.2. And that will give us 105 meters cubed for the volume. And for the last problem, find the volume of a right hexagonal prism that has a height of 10 and whose base is a regular hexagon with a side of 6 centimeters. Round to the nearest cubic centimeter. Okay, for this problem, we're going to need to find volume. So volume of a prism is area of the base times the height. Now we don't have the area of the base, so we have to apply our 1/2 AP formula for the area of our base. Now the 1/2 AP, the little a stands for the apothem, which is the segment that goes from the center of the hexagon at a 90-degree angle to the base, and then we have our radius drawn. Now because these are 120-degree angles outside on the hexagon, we have a 60 and a 30-degree angle in this little triangle. It says that the side of the hexagon is 6, so if this is 6, this part is 3 and 3, so we can use our HSL, or 30, 60, 90 right triangle, to get the apothem, which is going to be the long side of the right triangle, which will be 3 radical 3, because you multiply the short side by radical 3 to get the long leg. So we can do 1/2 A, which is 3 radical 3, times the perimeter. There's 6 sides of 6, so 6 times 6 is 36 for the perimeter. So we can calculate all that out to get the area of our base. So we can leave it in radical form. So 36 times 3, and then divide that by 2, and that's 54 radical 3. So that's 54 radical 3 for the area of our base. And it tells us our height is 10, so we can just substitute that in. So we get 540 radical 3, but they want us to round to the nearest cubic centimeter, so we have to multiply that out. So 540 times radical 3 is 935.31, and this is in centimeters cubed.